All right, well, welcome back. This is lesson 12. It's on Docker containers. Once again, it's a 60-minute lecture with a 25-minute practice. We may not be quite 60 minutes, but once again, for the longer lectures like we had before, we'll take a break in the middle, all right? That way it's not quite so monotonous. And so the practice, yeah, it's all 25 minutes. And at this point, once again, it's one of the ones I'd encourage you very much to do, to become familiar with. We're going to describe the purpose of Docker. Docker is to create lightweight, secure, small containers. All right. We'll take a look at Docker images, which come from the Docker Hub registry. We'll get Docker installed. We'll get it started, get it enabled. We'll search and download images from the Docker Hub registry. Now, a caveat, and I'll mention this again during the lecture component. The material here was assembled a year ago, maybe 15 months. And in that last 15 months, the Docker Hub registry has just exploded. It really, really has. So we'll show you what it looked like. We'll get you some Oracle stuff, all right? But there's a whole bunch of new apps that are out there now. We'll view Docker container logs and information about those images you've downloaded. Create, stop, start, and remove Docker lightweight containers. Create a Docker image from a Docker container or a Docker file. Save a Docker container and image for exporting. Load an exported Docker container or image. Think portability, all right. And then lastly, WLS, Oracle's WebLogic server, is now Docker certified. And Oracle's been working real closely with Docker to be sure that we're very much in step with the direction that Docker wants to take. First bullet, Docker provides a means of building and packaging applications into lightweight containers. Now what that means is, if we used Linux containers, they've got a bigger footprint. They have more files. If we move up we got these lightweight containers from Docker. We have Linux containers, and they have a bigger footprint. And then if we move all the way up to a VM, the VMs are huge because they're a full operating system. And so the Docker images consist of a Docker engine, obviously a runtime and packaging tool, and then a cloud service, the Docker Hub registry, for sharing applications. Use Docker to create image-based application containers. The application is packaged with an individual runtime stack. And all that Docker container contains is what's needed to run that application. No, you don't need a whole operating system like you do when you run a virtual machine, a VM, like the VMs that we're using here in this class. With Docker, you can transfer the container to any machine that runs Docker. Current time frame is early in 2017. Obviously, initially, Docker was a Linux-based activity. There's now Docker for Unix. There's also Docker for Microsoft. That came out last summer. Okay. And so Docker now can build an image, and you can run it literally on all the platforms inside your organization. Once again, think portability. Their bottom bullet, very important. As you look at the containers, they are small, fast, and if I was the curriculum developer, I probably would have used an adjective, very secure. All right, just really are. So the containers are built from images. And so in this line here, that's the Docker image. And so that's the image, all right? And so what we're going to create is we're going to create a something called guest, all right? And that guest is going to launch bin bash. Not that dissimilar from a VM, okay? And so if you were in somebody's virtual machine environment, like ours here with OVS, when you sign on, you get bin bash. The Docker images consist of a series of layers. The base layer provides a runtime. Each instruction adds another layer, and the application container runs on the top layer. Okay? Docker provides the capability to build Docker images or update existing images in your environment. Now, to go back to the Docker Hub, you're going to need some more credentials, and you're going to need approval by Docker. All right, but we'll talk about that in just a moment. The way to build an image is stored inside that Docker file. So you actually give instructions as you build the file on how you want that image to be constructed. And the notion is, they talk here about sharing with others, and certainly that I would consider to be sharing to be a big issue, but I like the word portability, particularly when I can move between Linux and Unix and Windows. All right, those are all good things. Oh, it was late in 2015. Oracle had been working with Docker for, I think, about a year. And we finally got approval to upload that Oracle Linux 7, Oracle Linux 6 as Docker images. And obviously the last slide in this material, we're going to talk about WLS. All right. And so now we are, I think, defined as a major contributor. All right. But if you had an application specialty that your organization had built, then your organization could apply for and meet the requirements of Docker and be the supplier of that particular Docker image. HTTPS registry hub docker.com/ and right here, although you may not be able to see it, there's an underscore between those two slashes. No, it's not a space. Okay. And then Oracle Linux, and we may even have 5 images out there. I haven't gone out to look recently. You need to create an account on Docker to use the available services, user authentication, automatic image builds and workflow tools, integration with GitHub and Bitbucket, and then loading images into the Docker Hub. So once again, you've got to go through a approval process. You've got to be made sure that Docker really wants your images. Okay. Once there, those images that you create are available for anybody to download. You don't have to have the credentials from the previous bullet just to be able to download a Docker image. Here's a screenshot of Docker. Once again, time frame was probably late in 2015. And so under the Oracle 7 Linux, that bullet right there, You notice that they have latest 7.7.1. This class, which followed this time frame, is 7.2. And if you recall, Al's recommendation was that if you're doing a new install, that you really install 7 Update 3. Okay? And so, once again, my expectation would be that this screen would be much different. At that time frame, we had 6 Update 6. It's 6 Update 7, 6 Update 8. 5.11, that's about all it is, all right? 5 hasn't moved much. 5.11 is very, very stable. Both that kind of time frame for Oracle and for Red Hat still has a fairly large group of customers running on it. Why? Because it's stable. And we're still supplying updates for 11. Remember, only the most latest update in release 7 or release 6 or release 5 gets security updates, as a matter of course. Yum, install Docker. It comes from the ULN channel, all right? So once again, you've got to be getting your support from Oracle. We then go out and we do a systemctl enable. We've done this before. And then we do a systemctl start. And the start starts it now, and the enable allows it to restart when the box reboots. The default device mapper, the device mapper is the default storage driver. Let me get that out right. But Oracle Linux 7, in addition to SGI's XFS, also supports the B-tree file system as a storage driver. You should know that BTRFS is written initially by Oracle. All right. And if you're curious, you can go do status BTRFS on the web, and they'll bring you up a status page and show you what's good, what's still in flux, and what's not working. Now, as you know from the introduction I did at the beginning, I've been in IT 40 years. Oracle initially started work on BTRFS 10 years ago. Now, trust me, it doesn't take 10 years to write a file system. But if you've been in IT a long time too, you're very aware that projects often get a life of their own. And we have something called project creep. And so while you had a nicely well-defined project, and this is how it started out, then it becomes larger and larger and larger and larger. And so now, I think BTRFS includes everything except the kitchen sink. All right? But it's a very good file system. And I think at some point in time, Red Hat will move away from XFS and go back and embrace BTRFS. There's a Docker utility. There's over 30 commands. No, we don't have them all here on the page. We just don't, all right? You can run Docker without arguments. There's a man page that you got from the previous yum install. You can build, create, exec info, kill, pull, run, search, start, stop, all sorts of stuff, you know. And just because you downloaded a Docker image doesn't mean that it passed muster and you're going to use it. You can delete it. All right, that's part of it. Because Docker uses device mapper, you can certainly substitute BTRFS for device mapper and take advantage of obviously the BTRFS snapshot. Once again, that snapper tool that we talked about is an additional program. And with the LWP, that's lightweight processes, all right? You may not have Snapper installed. And so you'd need to use a snapshot from within BTRFS. You need a block device, and certainly Device Mapper can get me there. And then in etc systemd var-lib-docker.mount, you'll enable the docker.mount target. Now, not everything works and plays well with security enhanced Linux. And so the default mode, after having done an install, like you did early in this course, SE Linux is enforcing. And so to make this Docker component work, you've got to set it to permissive. Permissive still does some logging. Read that as overhead. You may end up disabling SE Linux and rebooting your host. Set the options variable, edit the docker.service, and then enable and start that service. The Oracle Linux admin guide gives you some very, very good details with regard to that. Do we give you? No, we don't give you the URL. So, I have done a Docker search on the word Linux. And I've got Conical's Ubuntu there. Personally, on my own laptops, I use Ubuntu. Debian, a Linux distribution. Kali Linux, Oracle Linux. Now, surprisingly enough, when this was made, today, there's Fedora, there's Red Hat, there's a whole bunch of other Linuxes that are out there that you can choose for images and then be able to download them. So what I have is a Docker pull command. Allows me to go out and pull that image, and then the Docker images allows me to list those images that I had that are locally pulled. Okay, and it says 3 days ago, 3 weeks ago, last year, possibly. All right. And so you can go get them, you can try them, and then if you like them, you can use them. If you don't like them, then you can get rid of them. Try it if you like it. You know, I mean, I get really excited about Docker, and I smile a lot about Docker. I have no money invested in Docker. I think it's a good idea. You know, once again, having been in IT 40 years, there were times when IT projects took years, kind of like BTRFS, okay? So before we move on with actually running a Docker container, let's take a break. All right, well, welcome back. So you've gone out, you've downloaded an image from Docker. And so what you want to do now is you want to run that image, okay? And so obviously there's a Docker run command. Here we're going to use the Oracle Linux, and we'll use Ben Echo and say, hello. I probably would have said hello world, but you know, there's a little bit of a C programmer in me, all right, there just is. The next command generates an error. Why? Because we didn't download it. And when we did the search for Linux a little bit earlier, Fedora didn't show up. Now, once again, that screen image was 15 months old, 16 months old, something like that. Trust me, Today there's a Fedora out there. Probably Fedora 23. I think that's the most current version. But once again, I'm not in the Red Hat camp anymore. And really after 2006, I really haven't done much Red Hat because 2006 is when Oracle released Oracle Linux. Okay. And I quickly moved over to Oracle Linux and moved away from Red Hat. But prior to that, golly gee, we were a big Red Hat company. Just really, really were. Okay. So, unable to find, it then goes out pulling from Fedora. So it knows now that there is a Fedora available, and it goes and gets it for you. Not bad. Not bad. So over in the etc Oracle release file, it shows that we're running 7.1. In this case, we're running 7.2. Docker run T and an I, which allows me to run as an interactive container. All right. Oracle Linux 6, update 6, bin bash. And once again, that was all that was available from the Docker Hub so many months ago. The next one down here is Ubuntu, and it's the 14.04 long-term support, trusty tar. All right. And once again, I'm close to Conical, and from a consumer point of view, I find Ubuntu or Mint, which is based upon Ubuntu, to be a very satisfactory release. We talked about this earlier, all right, in another lesson. Here we have a Docker PS command, process status, just like the PS command that you've been running at the command line. But that PS command line tool is really not Docker aware, okay? And so you'll use the PS command from inside of Docker, all right? And so now we've got Oracle Linux 6 running bin bash, Ubuntu 14.04 running hello, okay? And so once again, as you move out into newer technologies, and I would tell you the addition here of systemd to Linux 7 is new technology. And our good friends at Fedora are currently working on a Danified update to Yum, all right, to clean it up. You're going to see some changes here over the next couple of years. At least that's Al's expectation. Lastly, we have Docker logs. And so you get information from within those environments. We can do a Docker inspect command to view low-level information. And so here you use the -F with the section subsection to display a very specific piece of information. And so the -F, network settings, IP addresses. And so we've got a 172.17.0.10, which is the default starting IP address as you go in and take a look at a Docker environment. All right. And once again, there's a lot of things that you can inspect, all right, inside of Docker. Once again, we'll touch briefly. We don't have a real long practice. We'll let you see what's there and then let you take a look at all that would be available. Tell you what, to give you a good feel, let me go out here and let's escape this. And so here's a Docker inspect on lonely hop. And so open square bracket, open curly. Now, once again, down here, obviously, I'm not sure that we want to add a whole lot more paper or PDFs to this image, but that gives you some of the names. God, do I know the names? No, I don't know the names. But could I at least give this as a place to start to go out and fully use that inspect command? Certainly could. Creating a new container. We have a create command. Once again, the I and the T are to create an interactive. The name is guest. It comes from Oracle Linux 6. I have a cursor here somewhere. There we go. All right. And once again, while this is an Oracle Linux 7 class, 6, update 8. Very stable, very good. Doesn't use systemd, it uses init. All right. And it doesn't use all of the new features that we've talked about through this course, but it's a very stable, very rock solid release. Okay. And so if you had an interest there, you could. And then I think we already showed you that 5.11 has for years been the last release of 5. No, I can't tell you if they're going to do another one. I'm not in that group. I'm an instructor, all right? Now, part of what gets created is that number. And you notice now I can do a Docker PS -A pipe grep for the number. And it comes back and tells me it's Oracle Linux 6. We're running bin bash, and the name of the container is guest. Okay. Now, I have talked to Craig. I'm not so sure everything needs to be called guest. It probably needs a little more detail than that. And so your names probably need to be specific right around the application that you're trying to run. Okay. So I can start a container, I can stop a container, or if I no longer need the container, I have a Docker RM command. Now notice if you're an RM aficionado, then you know that RM-F file's gone. If you don't have the -F, it's going to say, well, are you sure? Or in this case, it's a running container. You got to stop it, then delete it. But the -F option does allow me to do what we would in Docker call a force. So you start a container. And when you start that container has a default process that's running. And so we can go out and do an exec execute, all right? Once again, the T and the I or the I and the T, the order doesn't matter. They just both have to be there. And then that starts another command. And in Docker, remember that other command creates another layer. All right? And so in all of the layers in Docker, the top command is the command you're running. Here we've gone and done an SSHD, secure shell daemon, and we have SSH2, SSH1, both of which use Ribes, Shamir, and Adelman, RSA. And then with SSH2, there's also digital signature authority and elliptic curve DSA. These are all different encryption mechanisms. From 1978, I remember the 70s, Rives, Shamir, and Adelman were the graduate mathematics majors at MIT who came up with open key exchange, public key exchange. We moved up from their encryption method to DSA, digital signature authority, and then today we have elliptic curve, digital signature authority, which I don't think I fully understand what it does, but I think it's kind of like adding salt as you go out and do encryption. All right, that's what that's about. If you know more about encryption than me, you'll have understood what I said. Create an image. We do that with a Docker commit command. And so we've done the Docker run, new guest bin bash. We get a new guest prompt, yum install -y, httpd, then exit. And we then do a Docker commit. And we've given a -m here to tell us that we installed HTTP on Oracle Linux 7. I think I've already told you that I'm not the guy to do documentation. I'm just not. But a little bit of footprints in the sand go a long way to help those people who follow you. All right? And please, please, please try not to make them too cryptic. All right? They are footprints in the sand. They are meant for people to take a look at them and have some idea of what you're talking about. And though when we do the Docker images, we now have this column called tag, and that's the colon here. There we go, all right? So that created an image from a container. You can also create an image from a Docker file. Remember earlier I said all of the instructions for building an image are contained in that file. That's kind of what the first bullet here says too, all right? You can create a new directory and create the file named, surprise, surprise, Docker file. Use the Docker build command. Use the -t option to specify the repository name and tag, and then provide the path to the Docker file. I can save, I can load, okay? And so we put the save file into a tape archive format, okay? You can use the -o option in the command to write the output to a file rather than to standard out. Now, obviously, we redirected the output during the execution of the command, because where does it normally go? Standard out. File 1, all right? And so here, we've actually given it a file name, or you could use the -o option. Your choice. I happen to like this, but then I'm real comfortable with Bourne shell, corn shell, and bash. Don't ask me a lot of C shell questions. That may not be good. And so the example -o equals and the file name. And so probably we should say -o equal option, all right? And then Docker load can take this saved tar file and use it to load. I mean, I can't say enough good things about Docker, all right? And when you can take an already running application that closely meets your needs and have it up like that, you don't take years, months, weeks. You take hours in a day. I've been around IT long enough to know that's remarkable. All right, just is. Now, because we are a large vendor, we were able to get certification for WLS, WebLogic Server. And it's certified to run on Docker containers. And so if you were looking for a web server, that's downloadable from Docker. No configuration, very little work, it's set up and running. Really does have some advantages. Docker files and supporting scripts to build WebLogic services are available on GitHub. Okay. Docker files and scripts enable users to create clustered and non-clustered Oracle WebLogic server domain configurations. And then every server running the resulting domain runs its own Docker container and is capable of communicating with the other servers as required. Pretty neat, pretty neat. I need to give you some URLs, all right? And those URLs are embedded in the bottom of the page. They show up here in your PDFs as you download them. They too should be read, all right? So here's GitHub, then Tech Network, middleware, WebLogic, and the WebLogic server Docker containers PDF. There's a YouTube video. Oracle has made a lot of movement in using a YouTube video type of framework. A lot of people are used to going out to YouTube and looking on how to fix things. All right? And I may be guilty of that as well. And then the last one there are blogs. And so we have folks from the WLS development team who blog and give you helpful directions, helpful interaction. Which of the following are true? I'll give you a moment to think about them. Docker images contain only the content needed to run an application, so they are smaller than VMs. We may have even talked about that. A Docker container includes its own network interfaces, file system, and memory. Yep. An application running in a Docker container is isolated and very secure from other processes on the host computer. We may not have talked a lot about that, but the notion is with the container architecture, it's another approach to virtualization without a hypervisor. So you could literally have a host machine and you could have dozens of varying Docker containers. All right. With Docker containers, you can run the same application unchanged on laptops, data center virtual machines, any cloud environment that you would have across Linux, Unix, Windows. And now that I say that, there may also be a Mac environment. Go to Docker Hub Registry and see if you can find a Mac environment as well. All right, that's pretty common. So, let's escape this screen. A, B, C, D. Sounds like all of them are correct. Which of the following are true? Docker containers are created from Docker images. We did that. You can run an application as a daemon inside of a Docker container. We did that with SSHD. You can run an interactive application inside a Docker container. And users other than root can run Docker commands. Now, they may require configuration through the etc_sudoers file. Most of the things, though, if I bring up an environment and you attach the environment, you're going to need a user ID. So no, they don't always have to be root. ABCD again. All right, that's what we did. And you now have SSFTP to upload Docker images from Dome 0 to one of the VMs. You'll configure Docker, you get Docker installed, and then you'll use Docker commands. 25 minutes, 30, something like that. A lab that I think is worth doing. So let's put you into the practice. You get to hear me talk you down through the practice, and we'll come back here and we'll do advanced networking. See you in just a bit. All right, this is the practice on Docker, okay? And once again, much like we did with the lecture component, this is really a snapshot in time that corresponds to when this material was produced. And of the things that are in this course, this is probably the one that is changed the most dramatically, and it literally changes from day to day. For Docker, we're going to upload the Docker packages and Docker images from Dome 0. Now, once again, you need to be installing the latest from the Oracle, publicyum.oracle.com, all right? We'll enable and start using systemctl, the Docker service. We'll display information about the Docker configuration, and we will load images into the local Docker repository on host 02. And there's, once again, Docker command line interfaces as well. Let's go do that first. So there are really 1, 2, and 3. Once again, this will be a fairly quick process. All right. That's page 1. So we're going to be root first on Dome 0. We're going to take the seed OBS seed pool SFWS software. All right. And there is a Fedora tar, an Oracle Linux tar, and a Ubuntu tar. And we're going to take and move those either with secure FTP or secure copy. All right. So let's start with that. Let's see what I have back here. No. There it is. And so once again, I'm root. I'm connected here on host 02. All right, and I'm in root's home directory. And according to the directions here, we really want to start out on Dome 0. And so I'm in the OBS running pool for host 04. Kind of seems like that's the last one that I started. All right. So I'm going to go up a level here, back 2 levels. So I'm in the seed pool software, and then there are the Fedora tar, the Oracle Linux tar, and the Ubuntu tar. All right, and those I believe were the 3 files that we were looking for here. And so we want to get those 3 files over to host 02. All right. There we go. Honestly, it doesn't matter whether you use the secure file transfer or secure copy. The good news is that all of the packages are encrypted. And so if I'll go to host 02 and I'll do a pwd, I'm in root, we'll do an ls, and there are the Fedora tar, the Oracle Linux tar, and the Ubuntu or Ubuntu tar. And so that piece of this has been successful. All right, so the next piece here for the 12-2 configure Docker. From host 02, we're going to use the systemctl command. So I'm going to be root over there on host 02. And so let's take an RPM command first. QA pipe grep for Docker. And so this is the 161 release. And if we'll take now, this was installed back in January of 2016. The build date is May of 2015. I can tell you that by today there are newer releases of Docker available. And once again, I would make sure that the vendor is Oracle America, because if you have issues with Docker and you were to open a service request with Oracle Support Services, they're going to ask for an SOS report. And in that SOS report, they're going to be looking for pieces and components that need to be updated. All right, because once again, there's been just a tremendous influx, if you will, of information on Docker. And because we are running here an unbreakable enterprise kernel, then the Docker packages have been modified to exploit these changes in the UEK kernel. So let's return back to the material here. And so we want to do a enable, a start, and a status on Docker. So systemctl, enable Docker, start Docker, and so we'll now come back with a status. And so Docker is active. We have a Docker service, the application container engine, and it's up and running. All right, so we're in good shape. We don't see any errors down here in the bottom, and so everything's up and going. Okay. So we're going to take some Docker commands here, like Docker version and Docker info. Okay. So that's my Docker version. And once again, it's the same 161 that I showed you a little bit earlier. Once again, if you were to install this at home, all right, you would find that it would be a much more recent version of Docker. And so here is some Docker information. Once again, to come just back up here just a little bit. We have 0 containers and 0 images, although we brought over 3 tar files. And we'll get those untarred and we'll get them loaded into the local repository. So load Docker images. We have some tar files that we copied over from Dome 0. We're going to use the Docker images command to list images stored in the local repository. Initially, there are none. All right, and so the Docker images we would expect to be empty. Clear. And as anticipated, nothing's there. All right. And so we're going to make sure that we're in the root directory, root's home directory. Docker load input Oracle Linux tar. And so there's a 6 update 6 image and then Oracle latest. And once again, certainly that latest is contemporary with when this material was produced, all right, back in 2016. But it is certainly not the Oracle latest image from Docker. It's just not. So let's start with pwd. I'm in root, all right. And so Docker load input and once again this will take just a few moments, shouldn't take long. He says waiting patiently. All right, there we go. And so we'll just return to images, and there are the 2 images. 6 update 6, which once again is contemporary with this time frame back in 2016. All right, and once again, it was the early part of 2016, and so it was actually produced in the latter part of 2015. We uploaded 3 other files here. Fedora tar. Good, cool. Ubuntu, or Ubuntu, depending on where you place the accent here. Once again, no. There we go. All right. Let's bring back up our images command. And so there's the 2 Oracle Linux, and then there's, once again, the latest Ubuntu and the latest Fedora. Once again, contemporary with the release date on this class, the end of 2015, the first of 2016. And so depending upon when you're taking this training on demand class, your mileage may vary, all right? And so the third practice here, we're going to create a Docker container. We're going to start and stop the container to display information, create a container for a different Linux distribution. All right. Create a container in a running Docker, execute a command in a running Docker container. And once again, we're root on host 02. That hasn't changed much. All right. So we're just going to type in the word Docker. Okay, and once again, we get a list of commands here. All right. Let's clear. Now, I tell you what, let's do. Let's take this. Let's pipe it into less. Obviously, by me having made the font here larger, and once again, I did that intentionally. All right, so it would be easier to see as I did the recording. But because the font is larger, well, it takes up more screen space. And so if you have the same sort of configuration at home, then once again, let less be your friend. All right, and once again, you've seen me use it all the way through this class. All right, and so that's page 2. Here's page 3. Here's page 4. All right, and so once again, I would encourage you not to be overwhelmed by the material, but to use the commands that are readily available in the operating system to help you. Okay? So we'll take Docker PS, and there are no Docker containers running yet. We'll take a look at A to see all of the containers that are there. And at this point in time, because we've not configured any, there are none there, and that would be our expectation. Nothing. Still nothing. And so the first part of this is to actually get us, based upon our images, a Docker container up and running. And so we're going to cover some ground again. And so we have, obviously, these 4 images that we can work with. Now, this is an operating system class. This is not an application class. So no, we didn't pick any Docker applications. Certainly, we can put together operating systems pretty easily in Docker. But I would tell you that where you get the most leverage or the biggest bang for the buck is when you use Docker apps. All right. Oh, there's my cursor. And so what we want to do here is Docker run Oracle Linux bin echo hello. All righty. And what we get is the actual error message that's expected. All right. And so this error message has to do with the fact that we are actually using security enhanced Linux. Okay. And so when we check it here in a minute, it's going to say enforcing. We're going to do a set enforce to 0. Going to turn enforcing into permissive, and we'll go back and rerun that command. All right. So git enforce, and it is enforcing. Set enforce permissive. And now as we run the Docker command, instead of getting permission denied, we get Docker to run. All right, which is what you would want, which is what you'd expect. All right. The command that we did just a moment ago, the ps command, shows that we have, once again, nothing really there. All right. That's running because this ran, produced its output, and Docker went away. If we'll do a -A to list all of the images, so now we have the Fedora latest, Oracle Linux latest, about a minute ago, and it didn't run successfully. And so now we've got these two images that are there, all right, and they were really created very effortlessly. No, we're going to do a ps command and a ps-a command. That would be what I would expect. All right. We're going to use the Docker create now to create a new container. The command creates a container similar to a Docker run. The Docker run creates a container that runs a command and then exits. The Docker create creates a container that you can start at a later date. And so start, stop, etc. And this container needs to have a name. And so we're going to do a create. The I is to keep standard in open, even if not attached. The T is to allocate a teletype, which could ultimately be used as a console. All right. And I remember when all we had was teletypes, long, long ago. All right. So let's clear. Docker create -I-T. We're going to call it guest. All right, how about I put the name in there? There we go. So Docker create -I-T-name guest Oracle Linux. And so there's a long unique number to identify it. And so PS, nothing running. Why? Because all we did was create, we did not start. And so now we have a name that we created. Now we've got this Silly Jones or Focus Thompson, I think one of the developers associated with it. All right. But once again, it is the most recent. The Silly Jones exited with a return status, an exit status of 0, and which tells you that it's successfully completed. Okay. So we did a create. We're now ready to do a start and a stop. Okay, and in between there we'll do a ps command. Start guest tells you guest has started. That ps command shows that it is up and running, and because we created it with the -I, that gives us the ability to keep standard in open. All right. So we did a start, we did a ps command. We now want to do a stop. And this stop is really kind of like a kill -15. And the PS tells me that once again, nothing's running, which is what your expectation should be, that nothing would be running. So this time we're going to start. attaches the containers standard out and standard error and forwards all signals to the process. The default is false, and the I attaches the containers standard in, and once again the default is false. And so we'll do a start -a-i, gives us a prompt. Okay. And I've got a prompt here. And so host name, it would be what we refer to here as the container ID, all right, that we saw from the docker ps command. A pwd shows that I'm in the root directory. An ls shows that I have these directories and or links set up. Okay. I'm running bash is what I would expect to be running. All right. ps-ef pipe wc-l. And there's only 4 processes running. The thing about Docker and Docker images is that they are very, 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 very lightweight. All right. df-h, continuing what's in the book, df-h, here we have what our storage is that's available by default in Docker. Okay. I need to go back and look. Oh, it's a cat for Etsy Oracle release. And so it ought to be 7.1. Well, let's take a look. It is as we would expect. And then we have the loopback adapter and we have ET80 already. And a 172.17.0.4 with a subnet mask that is 16. And so 255.255.0.0. All right. So we're going to take now and type an exit. We'll do a host name again to show you that we're back on host 02. And when we do the docker ps command, but Docker's gone. Why? Because you typed in the exit. All right. And so what's going to be very lightweight? So exit, host name, docker ps, that there is nothing running. And so let's go back here and start guest again. And it's up and running. It shows us that it's up and running. Okay. We now want to take a look at Docker logs for guest. And so what you see here are the commands that you have just run, all right, when we were signed on to Docker just a moment ago. And so those are all the commands, and that was what you would expect to find in the Docker logs. Here we'll go out and we'll do a Docker inspect guess. All right. And once again, let's pipe that into less. There we go. That looks more like what's in your book. And once again, there's a lot of lines of output. I mean, and once again, you take up like a full page in the book, and yet there are ellipses in it, so you still don't see it all. Page 1, page 2, page 3, page 4, page 5, page 6. Now, if I wanted to, maybe I would have put it out to a file called Docker inspect and given it a date and timestamp. All right, and that certainly could be a way to keep the information, and then I'd have a file that I could go back and take a look at later. Let's go back and do this again. All right. Because I want to inspect here network settings .ip address. Okay. And so back here, / network disabled, network mode, network settings. And what I'm looking for under network settings is IP address. And so once again, it's in the inspect. Now once again, if it's scrolled off your screen, you're not going to be able to do that, all right? So I'm going to do a quit. This time, in the inspect command, I'm going to use the -F, all right? And then I've got curly curly. There we go. Dot, capital NET, network, SET, settings, period, IP address, close curlies. And that starts with a period, not a comma. That's the same information, all right? And so whether you took just the inspect command, put it into a file, or pumped it into less, you can go down through and search and find anything that you could actually put a -F in to allow me to display just the contents of that one particular entry out of the overall inspect command. Okay. And that's the result. All right, so man pages for Docker create, and we'll use the / -net command to search the man pages for -- and then we'll use the letter N to do the search for the second occurrence. All right, so / net. There's the first finding. There's the second, and that's really the one that we were looking for, I believe. All right, and if we search again, that's it. So there's only 2 entries here inside the file, and so the network is a bridged network. It could be none, could be a container, it could be a host. All right, and so once again, if we take the Docker inspect command and look for this piece of information, we'll actually see that we are the default, which should be bridged. All right, I'm going to do a Q and get out. and it's bridged. Okay, once again, and what you did none of this. I mean, all you did was take the defaults in Docker. And so once again, while this does put together a very, very quick operating system, I mean, it was what? Within seconds. I'm not going to say it was instantaneous, as we did the docker create command. So that's bridged. That was what we wanted. Host 02 is running 7.2. All right, so we'll do an OS release here. And so 7.2, the ID is OL for Oracle Linux. And so there's all the detail that you would have had. A rating with Bugzilla, a support product from Oracle Linux, etc. All right. Okay, so we want to run Fedora, bin bash. All right. We'll do that same cat for etc OS release. It'll be Fedora. Once again, version 22. I think the current version is 26. Could be. Could be. All right. Docker run -t -i fedora bin bash. And so a cat here for etc OS release shows that it's Fedora 22. And once again, at the time this material is recorded, I think Fedora's most recent version is 26. Don't hold me to that. I could be wrong. And so host name as a command is not found. All right, but when I exit Fedora and get back to host 02, obviously that gets me where I am. We're going to take and do a Docker run, this time with Ubuntu. We'll do the same sort of information, put us back on host 02. Now, obviously, this is a 14.04 from Conical, and it is the LTS. It's the long-term support version of Ubuntu. And so, once again, there seems to be a 1404, 1410, 1504, 1510, 1604, 1610, ... All right. We'll do an exit. Host name, we're back on host 02, and that should get us down to question 6 here. Use Docker create to create a new container. Create the container from the Docker Linux 6 update 6 image and name the container OL6.6. All right. Let me be sure I got my syntax right. Create -i-t -name OL 6.6 with Oracle Linux : 66. Got it. All right, there it is, created. Shows that we now have this Oracle 6.6. All right, the name is OL 6.6. So that all seems to work. When they now wanted, I think, to start it. Yeah, start OL 6 and run some services here. Okay. And so we now want to start some additional services. In this environment. And so we'll use the docker exec command. And so status, stop. We'll do a start, we'll do a status again, tell us that it's okay. We'll do a check config, because once again, this is not Oracle Linux 7, but it is Oracle Linux 6. We'll do that on, then we'll do an SSHD to list that it's on. And so those are all ought to be pretty straightforward commands. dock docker exec OL 6.6 service and it comes back and tells you that it stopped, as we would expect. And so let's take, instead of doing the status, let's do a start. And it's now started. And we go back to the status and it says it's running. And gives me a process ID number. Okay. Once again, your PID may be the same, your PID may be different. All right. And so for run levels 2, 3, 4, 5, SSHD is on. And so we would expect when the box reboots that would be the process. Okay. Now, when you make changes like we've just done, those changes really are temporary unless you go out and create a Docker image, and we're going to use the Docker commit command to save the changes to this OL6 container to a new image. Okay? Because once again, if the image itself doesn't get updated, then the next time you start the image, you'd have to go back and redo all this work again. And once you get a configuration, you're good to go, but there is some work here. And this is just at the operating system level. If you're doing an app, then there'll be something else there as well. So docker commit m equals All right, so docker commit -m equals started SSHD on OL 6.6, close double quote, -a equals double quote my space name double quote OL 6.6. And so here is my mod SSH1 v1. All right, and you'll have that same first several positions of the image ID. All right. And so here is the images that have been created. We also have just the image command. Oh, how about plural, Al? Makes all the difference in the world there. And so here is the very newest entry that we created about a minute ago. All right. And it is a 403 easy 9011. And so 403 easy 9011. So that's the same beginning number sequence. And once again, it's unlikely that you would have multiples. Okay. And so that in a nutshell for the operating system is Docker. Now, this is Al. Is the best use of Docker to do an operating system? No, I think not. I think the best use is to do applications. Once again, this is, as I told you earlier, this is an operating system class. This is not an apps class. Come back to some of our new cloud training where we're actually putting together Docker apps. And that might be an interesting place to be. I'm going to disable Docker. I'm going to stop Docker. And I think that ends it.